In this video, I will explain how Microsoft Excel can be used to implement outcome-based education or OBE. In OBE, the most important part is measuring whether students are achieving the course learning outcomes or not. Each assessment, such as quizzes, assignments, or exams, is mapped to specific CLOs, and Excel can help us automatically calculate whether the student meets the required threshold or not. Let us look at this Excel sheet that tracks the CLO performance. So this sheet is very important in the OBE process because it allows the instructors to track individual student performance, identify weak learning outcomes, and measure CLO attainment automatically, and use this data later to compute program learning outcomes. So by using the Excel formulas, the entire CLO evaluation process becomes automated, transparent, and very easy to analyze. We will be referring to the course Software Re-engineering for this brief hands-on. First, we define the CLOs. These CLOs are the foundation of OBE assessment. Every quiz, assignment, project, and exam question must be mapped to one of these CLOs. And next, we move to assessment sheets. Each sheet represents a different evaluation component. For example, a quiz, case study, problem-based learning case study, midterm, and final exam. So each sheet contains student marks and CLO mapping. First, we have a basic student information column that shows the roll number, which uniquely identifies each student. After that, we have the quiz 1 column, which represents the marks obtained by the student. So in this case, quiz 1 has 10 total marks. This sheet counts how many CLOs are weak for each student or assessment using the formulas. So this helps the instructor to quickly identify the problem areas in the course outcomes. So you can see columns labeled as CLO1, CLO2, CLO3, and CLO4. Each column represents a course learning outcome for this course. And for each student, the Excel evaluates their performance and displays either 1 or true, meaning the CLO is achieved, and 0 or false, meaning the CLO is not achieved. So Excel uses true and false logical values, and these logical values are basically converted into numerical values like 1 and 0, so that Excel can perform the calculations such as averages and percentages. After entering the marks and mapping the questions to CLOs, Excel formulas are used to calculate the CLO attainment percentage. Next, this is a CLO contribution of each student. Now let's look at the formula used to calculate the CLO contribution for each student. So this is the formula. This formula starts with the if function, which allows the Excel to perform a logical test. So the structure of the if function is this, like we have if condition, then a part for true case, and finally the part for handling the false case. So Excel first checks the condition, and based on the result it returns a specific value. So the condition used here is C4 is equals to 1. This means the Excel checks whether the CLO mapping value is equals to 1 or not. So 1 means the quiz question is mapped to that CLO, and 0 means the quiz question is not mapped to that CLO. So if C4 is equals to 1, it means this CLO is covered by this assessment, that is covered by this quiz. Then we calculate the student percentage. So if the CLO is covered, Excel performs this calculation as B4 into C4 and so on. Let's break this down. First, B4 represents the marks obtained by the student in quiz 1. Next, C4 represents a CLO mapping value. Since it is 1 when the CLO is covered, multiplying by C4 ensures that the score is counted only for the relevant CLO. Then we divide by B3, which contains the total marks of the quiz. So the $sign here means this is absolute reference. So when the formula is copied to the other cells, the total marks cell will remain fixed. Finally, we multiply by 100 to convert the result into a percentage. If the condition C4 is equals to 1 is not satisfied, that means the CLO is not mapped to that assessment. So the formula returns 0 simply. So this ensures that the CLO receives no contribution from this quiz. So this formula is very important in the outcome-based education calculation process because it helps us to calculate the CLO-wise student performance, and it ensures that marks are counted only for mapped CLOs, and it helps you to convert the raw scores into percentage attainment values. So these percentages are later used to determine whether the CLO achievement threshold, such as 60% in this case, has been met. Now let's move on to weak CLO identification. So the sheet also contains a column labeled as count of weak CLOs. A weak CLO is defined as a CLO where the student performance is below 60% threshold. Excel automatically counts how many CLOs are weak for each student. So this helps the instructor quickly identify students who are struggling with certain learning outcomes. Now I will explain the Excel formula that is used to identify the weak course learning outcomes for each student. The formula used here is starting with the text join function. So this formula automatically identifies which CLOs are weak for a student based on the threshold. So the minimum attainment threshold is stored in cell M2, for example 60%. So you can later change it according to your course and the performance standards. If the student performance in any CLO is less than this threshold, then the CLO is considered weak. The formula starts with text join function that is used to combine multiple text values into one cell. The first argument is comma. This means each CLO name will be separated by a comma and a space. The second argument is true. This tells Excel to ignore empty values when combining the text. As a result, only the names of the weak CLOs will appear in the final list. Next, the formula checks each CLO individually using if and functions. So let's look at this part. The first part here, Excel checks two conditions. The first condition says H4 is less than M2. That basically checks whether the student's CLO1 attainment percentage is less than the threshold value that is stored in cell M2. Second condition, H3 is equals to true, checks whether CLO is actually covered in the course assessment. And function ensures that both conditions must be true. So if both conditions are satisfied, the Excel returns the text CLO1. If not, then Excel returns an empty value. So the same logic can be repeated for CLO2 that is based on column I, CLO3 using the column J, and CLO4 using the column K. So for each CLO, the Excel checks whether the student attainment is below the threshold. Secondly, whether the CLO is covered in that assessment. And if both conditions are true, then we will add that CLO name to our final result string. After checking all CLOs, the text join function combines the names of weak CLOs into one cell. So for example, the output might look like CLO2, CLO4. This means the student has not achieved the required threshold in CLO2 and CLO4. This formula is very useful again because it allows the instructor to quickly identify which CLOs are weak and to understand the learning gaps and plan improvement strategies for specific outcomes. So instead of manually checking every CLO, so this formula can help you to generate a list of weak learning outcomes. Now let's see how Excel counts the number of students who have CLO1 as a weak learning outcome. So the formula used is shown there. I will explain this formula step by step. So this formula uses COUNTIF function. So COUNTIF function in Excel is used to count the number of cells in a range that means a specific condition. General structure of COUNTIF is this, like COUNTIF, and takes two arguments, range and criteria. So Excel scans a range of cells and counts how many cells match a given criteria. So the first part of this formula is M4 colon M14. So this basically represents a range of cells that contains a list of weak CLOs for each student that we just calculated in the last step. Each cell in this column may contain values like CLO1, CLO2, CLO1, CLO3 and so on. So the dollar sign indicates again the absolute reference. Second part of the formula is CLO1 steric. So the steric symbols are wildcards in Excel. They mean that Excel should count any cell that contains the text CLO1 anywhere inside the cell. So this is important because some cells may contain multiple CLOs. So like comma separated values. So even in this case, the Excel will detect CLO1 within the text. After checking all the cells in the specified range, the Excel returns the total number of students who have CLO1 listed as a weak CLO. For example, if the result is 5, it means 5 students didn't meet the required threshold for CLO1. So the same formula structure can be used to count weak cases for other CLOs as well, as we have done for CLO1. So for example, for CLO2, the countif function will take CLO2 steric as a second argument and so on. So this helps us to automatically calculate how many students are weak in each CLO, to identify which CLOs are more problematic for students and may require improvement in strategies of teaching. Now I will explain how we calculate the frequency of weak CLOs. For example, let's take CLO1. Then the formula here will be again based on countif. So the formula calculates the proportion of students who have CLO1 as a weak learning outcome. So let's understand this formula. The first part of the formula is countif. The countif checks the range of cells and count how many cells match a specific condition. So this gives us the number of students who have CLO1 as a weak CLO. Then the second part of the formula is count A. So the count A function counts the number of non-empty cells in the range. So in this context, it represents the total number of students whose weak CLO data is recorded. And finally, the formula divides the two values. So Excel calculates number of students weak in CLO1 divided by the total number of students. So this gives us a proportion or frequency of weak CLO1 cases. For example, if 4 students are weak in CLO1 and total students are 10, then the frequency would be 40% or 0.4. So this calculation is again useful because it helps the instructor to decide and understand how widespread a learning problem is. If the frequency of weak CLO is very high, it means many students are struggling with the learning outcomes. So it is better to decide whether the teaching methods, assessment, or the course content needs some improvement or not. The same approach can also be used to calculate the frequency for CLO2, CLO4 and 3. Now let's see how to calculate the attainment of CLO. In OBE, a CLO is considered attained if a student performance reaches or exceeds a predefined threshold. So if you want to find out how many students have scored 60% or 70% or more in CLO1. So the first part of the formula is countif. So the countif checks each value in the range age 4 to age 14, and this range contains CLO1 percentage scores for all the students. Excel counts how many students have a value greater than or equal to 70. So these are the students who have successfully achieved the CLO. The second part of the formula, count A, counts the number of non-empty cells, again representing the total number of students whose CLO1 scores are recorded. The same approach can be applied to other CLO columns as well. For example, CLO2 might use the range I4 to I14. This automatically calculates the attainment level for each learning outcome. Now let's look at how Excel determines the status of each course learning outcome, whether it is achieved or it needs improvement. So this formula uses a function which performs a logical test and returns different results depending on whether the condition is true or false. Cell age 20 contains the calculated attainment percentage for CLO1. So Excel checks whether this value is greater than or equal to 70%. So if a condition is true, Excel returns the text achieved. This means that CLO attainment target has been successfully met. And if the condition is false, it returns needs improvement. So this indicates that the attainment level is below the required benchmark and the instructor may need to review the teaching method, assessments and course material. The same logic again can be applied to other CLO attainment cells as well. Now we will analyze the CLO results using a Pareto chart. A Pareto chart is a statistical tool that is used to identify the most significant problems in the dataset. It is based on Pareto principle, also known as 80-20 principle. So it states that around 80% of the effects usually come from 20% of the causes. So in the context of OBE, this means a small number of CLOs may be responsible for most of the student performance issues. So by using it, instructors can quickly identify which CLOs require the most attention and improvement. Pareto chart combines two types of visual information. First, we have bars, which represent the frequency or count of occurrences. In this case, the bars show how many students failed to achieve each CLO. Second, we have cumulative percentage line, which shows the running total contribution of each CLO to the overall problem. This helps us identify which CLO contribute most to the learning gaps. So using Pareto chart in OBE helps the instructor to identify critical learning outcomes where the students struggle the most, focus on improvement efforts on high impact CLOs, and make data driven decisions for course improvement. and improve the teaching strategies and assessment design. So instead of improving all the CLOs equally, the Pareto chart helps us to prioritize the CLOs that need the most attention. Consider the following CLO attainment data, like we have CLO1 as 85%, CLO2 as 40%, and so on. So the first step is to sort it in descending order. So we have now CLO4 at the top with 90%, then CLO1 as 85%, and so on. Then we have to calculate the cumulative percentage. So let's first calculate the total. The cumulative percentage is calculated to determine the progressive contribution of each CLO to the total attainment. So first, the attainment value of each CLO is divided by the overall total to obtain its individual percentage contribution. Then these percentages are added sequentially to compute the cumulative percentage. For instance, CLO4 has an attainment of 90 out of the total 265, which gives approximately 34%. Since it is the first value, its cumulative percentage is also 34%. Next, CLO1 has an attainment of 85, which corresponds to approximately 32% of the total. This value is then added to the previous cumulative percentage, that is 34%, resulting in a cumulative percentage of 66. So CLO1 will have a cumulative percentage of 66%. Then this process continues for all the remaining CLOs, allowing us to observe how each contributes to the overall attainment in the cumulative manner. The cumulative percentage is essential for constructing the Pareto line and identifying the point at which a significant portion of the total attainment is achieved, that typically lies around 80%. Now let's do some interpretation. So the Pareto chart shows that the first three CLOs like CLO4, CLO1 and CLO2 contribute to approximately 80% of the total attainment. However, CLO3 and CLO5 have relatively low attainment values and they represent weaker areas. So this helps the instructors to identify that improvement efforts should focus on CLO3 and 5 as they are contributing most to the performance gap. So this Pareto analysis then enables the educators to prioritize the corrective actions by focusing on the CLOs with the lowest attainment. So this targeted approach improves the teaching effectiveness and supports the continuous quality improvement in OBE systems. Now let's take a closer look at midterm sheet, which shows how student performed in each question and how it relates to CLOs. So this sheet is again organized into several important sections like identification of student, then the midterm questions, question 1 to 5, and then total marks. So again, as we have studied the formulas for calculating the weak CLOs and frequencies and attainment, same will be replicated to this. So this ensures that the assessment is aligned with the course outcomes. So that's it. Thanks for watching and stay tuned for more on OBE.